Hi everyone of Narayana 9th standard. Today I am here in front of you all to talk about the topic work power energy, assignment number 5. Now when we want to talk about this assignment, the first question which is given to you is, when a body moves in a circle, then work done by the centripetal force is always. The options given over here are positive, negative, 0 and none. So let us take the diagram of this. When a body moves in a circle, okay, there is a body and it is moving in a circle. It is moving in a circle. Let us take that body over here. It is moving in a circle. Now we do have a radius of the circle. We'll take, it has been tied up like this. It is moving in a circular path. Okay. Now the centripetal force of any body who is moving in a circular path is going to be towards the center. Let us write that force as centripetal force. I'll write it as Fc. It is being pulled towards the center. Now the displacement you can take upwards or downwards, it is your wish, clockwise or anti-clockwise. I am going to take anti-clockwise. Now this point, this is the particle and it is moving there, and I will draw a tangent from there. That tangent is nothing but your displacement over there. We have one displacement also. Now let us take these things to a side. Force, displacement. We have force and displacement. Now these two vectors are separated with an angle theta as 90 degrees. They are perpendicular to each other. Now when they are perpendicular to each other, that means the angle between them is 90 degrees. Now when you want to talk about the work done because of this force and displacement, work done formula W is equals to force into displacement, as it is a dot product, cos theta. F dot S cos theta is going to be equal to F dot S cos 90 degrees. Now what is the value of cos 90? Cos 90 is 0. Cos 90 is 0. F dot S into 0. Therefore, your work done is going to be, anything into 0 is going to be 0. This is 0. So, work done is 0. So, the first option is positive, second option is negative, third option is 0, fourth option is none. So, your answer for work done is 0, your option is 3. Now, let us go to the next question. Next question over here, you are going to talk about work done by a muscular force in holding a bob of a simple pendulum at its extreme position is. We will take a simple pendulum. Let us take this as a fixed point, your ceiling or whatever it is, a fixed rod which is fixed to a height, and take a string of length L and you connect it with a bob at the down. Now you do one thing, let us take the minimum starting point as M, that is main position. You try to pull it up to an extent, which is going to be called as an extreme position. This is an extreme position. And now if you leave it, definitely it moves towards this side, back to the main position. Again it's going to come to another position, another extreme position, which is going to be E, this side. Now when you want to talk about this, here you have pulled it to an extreme position. Imagine you are holding a ball in your hand. Now if you leave it, it goes into the motion and it falls down. But actually if it is in your hand, it is having no displacement. It doesn't have any displacement. So your displacement from the point where you are leaving it, like example a freely falling body, when it is not given down, it is in your hands, that means it is having no displacement. So your displacement is 0. So here they are asking about simple pendulum at its extreme position, work done they are asking. So, and work done by the muscular force. So the work done formula is W is equals to force into displacement cos theta. Now here force, displacement is 0, cos theta. Now when you try to calculate this, you have a 0 in the product. When you are having 0 in the product, your work done is going to be 0. So the work done is 0. Now let us go to the options. First option is 0, second option is positive, third option is negative, fourth option is none. So your correct answer over here is first one, which is 0. Your work done is 0. Let us go to the third question. Third question. When you want to talk about this third question, let me read the question for you all. If a body is moving with uniform velocity on a horizontal frictional surface, then work done by the net force on the body is. Okay, options given over here are 0, positive, negative and none. Let us go with these options. We will discuss about this question also. Now, if a body is moving with uniform velocity, okay, that's done. Very clearly you have to note this. Yeah, they are saying uniform velocity on a horizontal frictional surface. Let us take a surface which is frictional surface, horizontal surface, which I am drawing on x-axis like this, and you take a body of mass m, okay, and the friction is present over here, F, okay, and it is uniform velocity. So horizontal frictional surface, the work done by the net force. Now let us try to calculate the net force. Imagine I am applying some force over here which is called as net force, F net, and let us take the formula of force, F is equals to mass into acceleration. Everyone know that. Now here I want to talk about the acceleration formula first. Acceleration is nothing but change in velocity by time. So now change in velocity is v minus u by t. But here the word you can see here, the uniform velocity, they are telling it is uniform velocity. When you are talking about uniform velocity, that means there will be no change in velocity. If you are trying to subtract it, then your acceleration is going to be 0. Your acceleration is going to be 0. Now if your acceleration is 0, that means your force is 0. Your force is 0. You can write it over here, F is equals to 0. Now from this work done formula is going to be force into displacement cos theta. Now force is 0. If you want to multiply with 0 s cos theta, what you are going to get? 0 into anything is 0. So the work done is going to be 0. So your option is 1, 0. Right. Let us discuss another question. Now fourth question. Right. When we want to talk about this fourth question, let us see. When a person lifts a body from the ground to a height h by using a minimum lifting force F, then work done by lifting forces. Okay, we will take a body as they said. He is lifting a body from a ground. Let us take that body over here. We will take that body. This is the body of mass m. A person is lifting that body from the ground to a height h. Let us take, this is the ground. He just moved it up to a height h. Let us take that height h. Now he just moved it little up. Okay, the displacement over here is h. Now who is going to act down? One force is going to act down, that is weight force. Weight force, we can write W. Fw also you can write, F suffix W, which is mg, will be acting downwards. Now they are saying minimum lifting force. Minimum lifting force. Another point to be noted over here is minimum lifting force. When you want to talk about that minimum lifting force, that means you just have to overcome the weight, that's enough. You just have to overcome the weight. That means the minimum lifting force Fm is going to be equal to mg. Fm is going to be equal to mg. That is the minimum required force for you to move it up. Okay, now let us move it. It has moved. To how much distance did it move? It has moved to a distance of h. Now, force which you are applying, the minimum force which you are applying is upwards. Minimum force which you are applying is upwards. And the displacement is also upwards. So, I have to draw this perfectly because it's very important to understand the direction of the displacement. Now displacement is upwards. So I am going to draw two vectors, force vector F bar and displacement vector S bar. Both are parallel to each other, so the angle theta is going to be equal to 0. Angle theta is going to be equal to 0. So now let us talk about the work done formula. W is equals to F dot S cos theta. What is your force? Mg. Your force is mg. What is your displacement? H. What is the angle between these two vectors? 0. So I am going to write cos 0 degrees. So what is the value of cos 0? Everyone knows that, that is 1. So your answer is positive 1, that is mg h cos 0 is 1. So your work done is mg h, which is a positive work done. mgh, positive mgh, it's not minus mgh. See, when will you go to minus mgh is when you overcome the gravity. If they ask you about the gravitational force, then you are going to get it as negative force. But now here it is a minimum force for lifting. Lifting means upwards you have to lift. When you are trying to lift it upwards, definitely you have to take upward force only. So both are in the same direction and your angle is 0. But if you want to talk about the force due to the gravity, definitely you are going to get it as a negative. Let us see the next question. For getting a clear understanding about what I am telling right now, let us go to the next question. Now this question, when a person lifts a body from the ground to a height h by using a minimum lifting force F, the minimum work done by the gravitational forces. The minimum work done by the gravitational force. This is very important question. Like after talking about that previous question, it is better we discuss about this for getting a clear understanding. The same diagram I am going to draw again. Please make a note, everyone. So here you have a body of mass m. When a person lifts a body from the ground to a height h, he is lifting this body from the ground to a height h. Okay, he is lifting it. Let us take, he has already lifted it up to a height h. So the displacement over here is h and he has already lifted it. Now who is going to act downwards? Mg is going to act downwards, which is nothing but weight force. Fw I am writing. Okay, now let us talk about these two vectors. The minimum work done. Then minimum work done by the gravitational force, that is to be noted. Previously minimum work done by the man to lift that thing, but here gravitational force. Now let us talk about that. So W is equals to F dot S cos theta. Now what is your F value? What is your F value? Which force they ask you? They ask you about the gravitational force. So the gravitational force is mg. So I am going to take mg right? And which displacement they ask you? The displacement of the man who has lifted it to a height h. So displacement is h. Now let us draw these two vectors to a side. Vector 1 is displacement, vector 2 is weight. That is a force, weight force. I am going to write it as Fw. Now these two, if you see, these two vectors are opposite to each other. When these two vectors are opposite to each other, let us draw it horizontally to make you understand. Let us take this is displacement and this is force. Now what is the angle between them? 180 degrees. Angle between them is 180 degrees. So these both are opposite vectors. We call them as opposite vectors. Now if the angle is 180, the work done, if you try to substitute, the force is mg and displacement is h, and cos theta, which is cos 180 degrees, cos 180 is how much? Cos 180 is minus 1. Now if you want to substitute that, mg h and cos 180 is minus 1. So mgh into minus 1 is going to give you minus mgh. So your work done is a negative work done, which is going to be equal to minus mgh. First option, right? So fifth question is done. Let us go to our last question, which is sixth question. Now let us talk about the sixth question. Right, when a body is made to slide over a rough surface, the work done by the frictional forces. Very good question. The work done by the frictional force. Let us talk it in detail by drawing a diagram. In physics, it's very important to draw a diagram, right? Because that decides everything. Okay, there is a body of block. We'll take, when a body is made to slide over a rough surface, and I am going to draw a rough surface over here. This is your rough surface which I am taking. Now the work done by the frictional forces. See, anyway, if you try to push this side, let us apply some force F. If that block is trying to move that side, the force of friction will act in opposite direction to the motion of a body. Everyone knows that. Now this is moving that side, means friction will act opposite, because it is like you and me. If anyone says no, we will do it. No means yes for us. So in the same way, frictional force also does the same. It is going to come back. That means if the body is moving that side, the frictional force is going to be back. Okay. Now that acts in opposite direction of the body's motion. Now when a block is made to slide over a rough surface, the work done by the frictional forces, W is going to be equal to F dot S cos theta. Everyone knows that. Now whatever we talk, let us talk about the force. Which force they ask you to take over here? They ask you to take frictional force. They ask you to take frictional force. So frictional force is small f, and displacement, it is rolling. There is some displacement, yes. Now let us talk about the angle. So if you are applying force that side, if the block is moving, frictional force will be in opposite direction. So let us draw it in vector forms. Let us take this as frictional force. The block displacement is moving that side. Let us take this as S. The angle between them is 180 degrees. So the angle between these two vectors is 180 degrees, because frictional force is acting in this way and the body of mass m is moving that side. So F and S are in opposite direction. When they are opposite direction, the angle between them is 180 degrees. Now let us take cos 180 degrees. So your work done is going to be equal to F dot S cos 180 is nothing but minus 1. Now your work done W is going to be equal to minus Fs. So the work done by a body to make, if a body is made to slide over a rough surface, the work done by the frictional force is negative. Your option is negative, because you are going to get a negative work done answer over here, because they both are they both are apart, two vectors are apart from each other with 180 degrees, right? Had a nice time. Bye.